Hello and welcome back to another video about organic chemistry. My name's Chris. This is another of my videos which involves just a live lesson. There's no editing, there's no graphics, there's no script. I'm just going to do my best to explain the topic of electrophilic addition to unsymmetrical alkenes. So first of all, we need an unsymmetrical alkene. And you'll see what asymmetrical or unsymmetrical means now. This is propene. I'm sure you could predict that we only put one hydrogen on that carbon. So there's propene. And without going over all the stuff we did in the last video, we're going to add HBr, which has a dipole. And the dipole is explained in the previous video, which is also about electrophilic addition. Okay, so it's just the same as last time for the first step, except that we've got a little bit of a dilemma here because we've got a choice. We could either put the hydrogen on this carbon or we could put it on this carbon. We can't put it on this one because this carbon is not next to the double bond. We're going to put it on the first one, just for now. So we've got to make a decision somewhere, so we're going to put it on the first carbon. So now there's 3 on the first carbon. Now what that means is we're going to get what's called a carbocation, because the double bond's gone. And we've added a hydrogen. We've made a covalent bond between this carbon and this hydrogen. That's what we've done. And the other thing we've got, actually, I'll put it up here because otherwise it's going to be difficult to do the mechanism. So it's worth thinking ahead about where you're going to put things, because curly arrows can be as long as you like, but you don't really want great snakes and ladders things going on. So let's do that. Okay, and then the product's going to be, forget the bonds now because we've done the mechanism, so it's going to be CH3, CHBr, CH3. And this is called 2-bromopropane. And that is actually the major product. And well, I'll explain why this is the major product shortly. So the major product, and we need to know that because we need to know what we're making here. If you run a chemical company, you need to make pure chemicals and you need to know what you've got. We don't want mixtures. There's another possibility here. So what we'll do that down here. What if, so in the first one, we added the hydrogen to this carbon. What if we add it to this one? No reason why we couldn't. So we will. So the first carbon has only got 2 hydrogens on it. The second carbon has got 2 because we've added 1 to it, because we've got the hydrogen here. And of course, this one is unchanged because that bit is just like an alkane. It's very strong. Carbon-hydrogen bonds. Doesn't happen. But what we need is a positive charge on here, because this carbon atom has missed out basically on electrons. 2 electrons have moved out the double bond. 1 of them belonged to this carbon, if that's the right word. The other one didn't. So it's only a 1 positive because it's only really lost 1 electron effectively. And of course, now the bromine is going to latch on. That is not the technical term, by the way, for chemistry. It's going to bond with, that's a bit better, isn't it? the carbon. So now we've got CH2. I'm doing away with the bonds to save time. CH2, CH3. And I've often said that organic chemistry, a lot of it is really just about copying things out and changing one thing at a time. So of course this is 1 bromo propane. And what we can, well, that's the major product. This is going to be the minor product. And to explain this is a secondary carbocation, this thing. It's a carbon, it's got carbon, it's a cation. And it's secondary because there's 2 carbons attached to the one with the positive charge on it. So this is a secondary carbocation. And this one, because there's the carbon with the positive charge on it, it's only got 1 carbon on it. So this is a primary carbocation. Well, this one is more stable than this one. So this is more likely to be formed. And when it is formed, it's more likely to stay around because it's stable. And the thing that stabilizes it is alkyl groups. So this carbon, because it's secondary, it's got 2 alkyl groups. Alkyl just means carbon and hydrogen, unreactive. But these 2 alkyl groups push electron density towards the carbon with the positive on it, making it less positive, making it more stable. This one has only got 1 alkyl group, happens to be an ethyl group. So that only has 1 alkyl group pushing electrons towards the positive to stabilize it. So that's the explanation. That's the end of this video. If it was useful to you, then I'd be grateful if you click on the like button. The next video, which I will make tomorrow, is going to be not about electrophilic addition, but about nucleophilic substitution. So this is an electrophile. And what that means is, it's a very specific definition. It's an electron pair acceptor. That's what it's done. Now, a nucleophile, which is what we're going to do tomorrow, or whenever you're watching this, is going to be nucleophilic addition. Or substitution. We'll do substitution tomorrow. Okay, I hope it was useful. Hope to see you again. Thanks.